Hello, everyone. Welcome to today's session on light, that is about reflection and refraction. And today we will look into the refraction of light in detail. Okay. So earlier we learned about what is reflection, right? So let's quickly do a recap, right? So what is reflection? Let's say this is a mirror, which is at one end, this is polished. That means the light cannot pass through. So if a light ray hits on this, that's the incident ray. If I draw a normal to this, normal to the mirror, this is the angle of incidence. And as this is polished, all the light reflects back into the same medium. That is the angle of reflection. So that's what we learned about reflection, right? Now, what is refraction? So what if in this mirror, what if this the other side of the mirror is not polished, right? So when the other side of the mirror is not polished, that means the light can pass through that. The light can pass through that. So what will happen? Let's see. So this is the same mirror or a surface. So let's say the light ray is incidenting here, right? That is our incident ray. And if I draw a normal, right? If I draw a normal to the surface, so here, let's say this is the air, right? One side of the surface is air, and here, let's say glass or something, right? If this is the mirror, right? So if it is a mirror, and this is let's say this is inside the mirror, right? Let's say this is inside a glass mirror or whatever, or a glass slab. Now, this is the incident ray, which makes an angle I with the normal. Now, as this is the glass material, which is not polished or prevented for the light to move, so what will happen here? The light enters into this medium, that is glass, which is a thicker medium, right? Denser medium. So here, what happens is, usually light travels in which path, guys? Light travels in a straight line. So here, what happens is, the light speed gets slowed down as soon as it enters into the glass medium, which is a denser medium. The speed of the light gets reduced. So the light ray, instead of traveling straight, it bends towards the normal. Understood? So this is our angle of, sorry guys, this is our angle of refraction R. So this phenomenon of bending of the light when it enters from one medium to other medium is called refraction. You understood? So reflection is the other surface is kind of coated such that the light doesn't penetrate through that. All the light that falls is reflected back into the same medium. Here also, some of the lights get reflected back into the air, but some light gets refracted into that glass slab. So that process of getting into the glass slab by bending, uh, bending is nothing but the speed of the light gets slowed down, right? So in air is a less, what we call it as a uh, rarer medium, right? This is a rarer medium, and this is a denser medium. So when the light travels from one medium to other medium, the speed gets reduced or slowed down. So what happens is, ideally, this light should have traveled in a straight line. That means it should have traveled like this. You're following, right? So ideally, light should have traveled in the same direction in a straight line. But what happened here, because it is a denser medium, the speed of the lights got reduced and it slightly takes a different path, which is closer towards the normal, and then it continues into a straight line. So this process of bending of the light when it enters from a rarer medium to a denser medium is called refraction, right? So bending of the light from a rarer to denser medium, right? The bending of the light from rarer to dense medium is called refraction. So now we understood the difference between the reflection and refraction, right? So in reflection, all the light gets reflected into the same medium. For example, if this is air, everything gets reflected back into the air, and here I equal to R, right? I equal to R. But here I is not equal to R. Okay. So because it is a denser medium, the light speed gets reduced. So it bends towards the normal, to that plane. So when it bends normal to the plane, then I is not equal to R. Okay. So that is reflection and refraction. Now let's look at uh, the real-time examples of refraction where this refraction is helpful. So if you look at this, the pencil in water, right? So when you have a glass of water, right? If you put a pencil into that, what will happen at the surface where the air and water meets? At that surface, the bottom of the glass filled with water, that is a denser medium, and the uh, above the water you have an air, so that's a rarer medium. So when you keep a pencil in that, what will happen is you can check it, guys. So it appears that the pencil has bent at the surface, so that is because of the refraction. And also swimming pool, if you stand at the swimming pool, what you see is you see the swimming pool is much deeper than actually it is. That is because of the refraction. And also we use the lenses in cameras, microscopes, and also the spectacles. All those are made of lenses. Those lenses works based on the refraction principle, right? And then mirage in a desert. So if you go into a desert, you see that because of the uh, you will see that it is like a glassy finish kind of thing, or some places you feel like there is a water. Even on the roads we see that, right? Even on the highways, when we see at the noon times or in the afternoon time, you will feel that there is a water in front of us, but when we reach there is no water. So that is called a mirage. So it gives a impression that it's like a total internal reflection happens, so it shines, right? So that phenomenon is due to the refraction. And also in a rainy season, we see rainbow in the sky. So the formation of rainbow is also due to the refraction and scattering of the light in the water droplets when rain is coming. So that is also an example of refraction. So these are the real type examples. And also uh, why refraction happens, right? So this is a key thing that I wanted to cover, and this will help you guys. Like when light changes speed, right? So what will happen is, so in air, let's say I have two mediums here. So above it is air, and below, let's say this is glass or water, whatever, any dense medium. So in air, light travels fast compared to water. Then at the surface, what happens is, instead of taking that straight path, what it does is it takes a path that is closer to the normal. So this is angle of refraction and this is angle of incidence. So uh, light ray is moving faster, and when it enters into the denser medium, it moves slow compared to the air. So that's why it bends towards the normal. Now, what happens if a light ray is coming out of the, right? Let's say uh, this is an incident ray now, right? So I draw a normal here. So this is angle of incidence. If there is no refraction or bending, there's no speed change, it should have ideally followed the straight line path, right? But because this is a denser, let's say water, this is, and this is air. So it is moving from denser to a rarer medium. So what happens is it moves away from the normal. Hold on, guys. So away means it goes like this. So this is our angle of refraction. You understand? So a rarer medium to a denser medium, it bends towards the normal. When it goes in the opposite direction, from a denser medium to a rarer medium, it moves away from the normal. Okay? That's about the refraction, guys. So refraction is basically when there is a change in medium from denser to a rarer or rarer to a denser, there is a change in the speed of a light ray, and that reduces the speed that light can travel. So the light ray bends and travels. So that bending will happen based on from which medium to which medium. So if it is rarer to denser medium, the light ray bends towards the normal. If it is from denser to rarer, it bends away from the normal. Okay. All right, guys. Now let's see how this refraction or the light ray travels when it is a glass slab. Okay. So in a glass slab, what happens, guys? So basically here, there are two refractions happens. One is at this surface, right? At AB surface is one surface where it is entering from rarer to denser, and CD is the second surface where it is entering from denser to rarer. So let's say I'll draw here, right? As I still have the diagram, but I'll still draw for your better understanding, right? Let's say this is the glass slab. So, and I have a point where I'm planning to incident the light ray. Let's say the light ray has incident here with an angle of incidence I. Okay. Now, this is air, right? This is glass, which is the denser medium. So what will happen here, because it is a rarer to denser medium, ideally, the light ray should have traveled like this, guys, in a straight line. You agree? Yeah, I'm drawing with free hand, so it may not be straight, but yeah. So here, if I just extend this, so it bends towards the normal. That means instead of going in that direction, it travels like this. Now it hits the other surface. So that's again another angle of incidence, right? So let's say this is I1. This is another angle of incidence, that is I2, right? So here the light ray is traveling from denser medium to the rarer medium. So ideally, it should have traveled like this if it follows the same path, right? But it travels like this, away from the normal and parallel to this ray. So this is our angle of refraction. This is, let's say, R1, and this is our R2. Understood, guys? So what is happening is in a glass slab, the light ray undergoes refraction twice. One at the top surface, that is AB. The other one is at the bottom surface, that is CD. So here, air to glass at the first surface, and from glass to air at the second surface. So the light ray undergoes the deviation twice. And what we can observe here is, so here, its ideal path should be the dotted line if there was no medium change, right? The light travels in a straight line. Because it has a glass, so it is refracting and traveling in this path. So if you see this, the final refracted ray coming out of the glass slab and the virtual path of the light ray, they always are parallel. And this distance, the distance that I indicated with the X, that is the displacement of the light ray because of the refraction. So that's the displacement that will happen because of the light ray, because of the refraction due to the glass. So basically what is happening here, in a glass slab, the light ray refracts twice, right? Refract twice. One at the AB surface, that is from air to denser medium, that is glass. and it bends towards the normal, and then it hits the glass surface at CD, and then it emerges out. So this is the incident ray, and this is refracted ray, or we also called as emergent ray. Refracted ray or emergent ray, we can call it both. Okay, so the emergent ray is deviated from the virtual path of the light, and that displacement, that is the displacement of the ray caused by the glass slab, the bending of the light. So we can clearly see, right? So ideally it should have traveled in the straight line in the dotted line here, but it is traveling this way. It's moving x distance from the actual path. So that is the displacement of the light ray. Okay, this is how the light ray travels in a rectangular glass slab. Now, based on the refraction, there is a scientist Snell who has observed something, right? So let's see. So Snell law says that number one, the incident ray, comma, refracted ray, and the normal are in same plane. That's one thing, same plane. Number two, he has observed the ratio of sin I by sin R. So the sine ratio of incidence angle by the sine ratio of refracted angle is a constant. That's what he has observed for a given material. So that constant is denoted by mu, which is nothing but refractive index. That is nothing but refractive index of that particular material. So let's say I have a glass slab here, right? And the light ray is incidenting, and let's say this is the normal, and it's bending up, it's bending towards the normal. So this is angle of incidence and angle of refraction. Then this is the air, this is glass. Then that this surface, the sine ratio of the incident angle by the sine ratio of the refracted angle is a constant. That constant is nothing but mu, which is refractive index. Now, let's say I have two mediums, right? So air is 1 and glass is 2. Then mu of 2, 1, we call it as. So the refractive index of medium, that is glass, respective air, is this is basically the ratio of the speeds of the light. So that is, we call it as speed of light in air, or medium 1, to the speed of light in glass, or medium 2. Similarly, if we need mu 1, 2, that means the mu of air respective the glass. That means if the ray is traveling from glass to air, then it is the opposite to that. So speed of light in glass by speed of light in air. Okay, so basically the refractive index is relative. It's relative to the medium. So it can be from air to the glass or glass to the air. Okay, so that's Snell's law. Snell's law states that the sine ratios of incident and refractive angles is a constant, and that constant is called refractive index. Now, here, this table is from your textbook, and these are the different materials whose refractive index. Okay. For air, let's say air, that's where light travels faster compared to the other mediums, right? So air, it is almost 1. The refractive index of air is 1. So then ice, water, in water it is 1.33. That means light travels slower in water than air. Similarly, alcohol, kerosene. And if you look at this, the refractive index of diamond is the highest. That means light travels very, very slow in diamond. Okay, so that's about refraction of light and the Snell's law. Okay, so let's do a quick recap. Okay, so what we learned here, what is refraction of light? So we learned about reflection. Now we learned about what is the bending of the light from one medium to the other medium when there is a medium change. So that phenomenon is called refraction. And here in a denser medium, light travels slow and bends towards the normal, and in a rarer medium, so when the light is traveling from denser medium to rarer medium, from slow to faster it is, right? From slow speed to, once it enters into the rarer medium, it starts moving fast, so it moves away from the normal. And we also looked at where we can see this refraction phenomenon. So that's in the camera lenses or the optical spectacles that we use, rainbow, mirage, right? All those are the examples of refraction. And then we looked at how the light ray travels to a glass slab. So in the glass slab, the light ray undergoes two refractions. One is at the surface AB and the other one is at the surface CD. Okay, twice it undergoes. And there is a lateral displacements that happens. So there is a lateral displacement of the light ray that happens at glass slab, which the emergent ray comes parallel to the actual path of the light. Then we also learn about what is Snell's law. Snell's law is mu equal to sin I by sin R. So where I is the angle of incidence and R is the angle of refraction. And this is mu21 and 12. This is with respect to the mediums. So mu21 means the refractive index of medium 2 respect to medium 1. When mu12 is refractive index of 1 with respect to 2. It's a relative index it is, right? And then we looked at for different materials. So air has the least refractive index and diamond has the highest refractive index. So that's all for today's session. So I hope you guys understood the topic, and I'll see you next time. If you have any queries, you can connect me through my Urban Pro profile. Thank you, guys.